Have you ever looked at a simple computer game and just wondered, how does that actually work? Well, today we're going to do just that. We're going to pull back the curtain and break down this fun little Python animal race, line by simple line. So this is the game. It's super simple. You enter how fast you can run, and the game tells you which animal you are. But here's the crazy part. This whole thing, everything you see, is built with just 15 lines of code. So let's dive in and see exactly how it's done. All right, first things first. Every race needs racers, right? So how do we get our digital animals stored inside the code? We start right at the top on line 1. We're creating something called a list. Honestly, the best way to think about it is just like a container. We've given our container the name animals, and inside it we've put all our competitors, the dog, the cat, the rabbit, and so on. So, what is a list, technically? In Python, it's just a collection of items that's ordered and changeable. And that word, ordered, is super important for our game, because the position of each animal in that list is how we're going to pick it out later. And here's a really key concept in programming, something you just have to get used to: how computers count. To get something from a list, we use its position, or its index. But, and this is the big one, computers always start counting from 0. So the first item is index 0, the second is index 1, and you get the idea. Let's make that real for a second. If we want to grab the dog from our list, we don't ask for item 1. We ask for animals 0. And if we want the lion, we'd ask for animals 3. Seriously, remembering that zero-based counting is one of those things that will save you so much confusion down the road.
Okay, so we've got our racers lined up. But it's not much of a game if the player can't do anything, right? So the next step has to be getting their speed.
Now, this single line of code here handles all of that player interaction. I know it might look a little busy, but I promise it's really just 2 simple commands that are working together: to ask the user a question and then grab their answer.
Let's break it down from the inside out. It makes it easier. First, you have the input function. That's what puts the message on the screen and then just waits for you to type. Whatever you type, it snags it as plain old text. Then it hands that text over to the int function, which does one job. It converts that text into an integer, a whole number.
But hang on a minute. Why do we even need that extra step? Why bother with the int part at all? Can't we just use the text that the player typed in?
Well, the answer is pretty simple. You can't do math with text. We need to check if the player's speed is greater than 10 or greater than 20. And by turning their input into a real number, we give our program the power to actually make those comparisons. That's the entire logic of our game. And that brings us perfectly to the brains of the whole operation. We've got the racers, we've got the player's speed, so how does the code decide which animal you are? This whole block right here, this is our decision maker. It's basically a series of checkpoints. It looks at that speed variable we just made, and based on what number is inside it, it chooses exactly one path to follow. This whole process is called control flow. A great way to picture it is like a waterfall. The program starts at the very top at that first if statement. If the condition is true, boom, it runs the code inside and it's done. It ignores everything else. But if it's false, the program flows down to the next check. So the first test is the speed greater than 30? Let's say you typed in 45. The answer is yes. So the program prints out that you're as fast as a lion, and then its job is done. The whole process stops right there because it found a match. Okay, but what if you entered 25? Well, that first check is speed greater than 30. That's false. So the code just flows down to the next checkpoint, the elif statement, which just means else if. Now it asks, is the speed greater than 20? Yep, it is. So it prints the dog message, and again, stops right there. So what happens if none of those conditions are true? That's where the else statement comes in. It's the final safety net. It's the catch-all that only runs if every single check above it was false. In our game, that means you're being compared to a turtle. Oh, and see that little F right before the quote marks in the print statements? That's a super handy Python feature called an F string. It's awesome. It lets us pop variables, like our animals, directly inside our text. So when Python sees @animals3, it just swaps it out with the actual item from our list, in this case, the lion. So we've looked at the pieces, right? We've got the list, the user input, and the logic. Now let's just zoom out and put it all together to see the whole program run. And here it is again, the whole shebang. It's actually a pretty elegant flow when you see it all at once. It sets up the list of animals, it asks the player for their speed, and then it uses that if, elif, else logic to check that speed and print out a result. That's it. That's the entire game. So,
if you're going to remember anything from this, what are the big ideas? Well, first, we use lists to hold our data. We get information from the user with input, and we make sure it's a number using int. Then we make all our decisions with if, elif, and else. And finally, we build our messages using those handy f-strings. Honestly, these are the fundamental building blocks for so much programming.
And that really brings us to the big idea here. All this code really does is take a number, our speed, and sort it into a category. You can use this exact same logic, this same structure to sort anything. You could turn test scores into grades, or ages into different groups, or prices into discount levels. So the real question isn't just how this code works, but what problem could you solve with it?